everybody. Thanks to for coming to our next session. Sorry for that. We have to I had to do some changes here, and it's because of we have announced new stuff and changed everything almost completely. Who of you has attended the keynote before? Okay, most of you. Okay, then I will continue with this talk and jump into a little bit more details. And this talk, of course, is all about how you can accelerate your database applications by using Java in-memory computing and use Java as an in-memory caching layer between your application and your database. In this session, I like to introduce you to the fastest technology where you can build ultra-fast database applications with Java. And so we will go a little bit into more detail, and I try to explain the functional principle. And of course, you can ask questions. So my name is Markus Kett. I'm CEO, co-founder of MicroStream, the company behind the project Eclipse Store, Eclipse Serializer. We, with our company, contribute for around 12, 13 years to various open source projects. We started with the Eclipse based Java IDE called RapidClips, and this is a visual Java development environment based on the Eclipse IDE. And here we worked a long time on improving the JBoss Hibernate tools, and worked also on a UI designer for Java Swing and then for JavaFX. Then we built a Vaadin UI designer. The whole framework is open source. And with this project, we learned a lot about Hibernate programming. Of course, we saw a lot of customer applications, and we're in contact with many customers who had Hibernate issues, performance issues with their database, and so did a lot of database migrating. And one day we recognized we cannot solve this problem. So. And this was the reason why we started the Eclipse Store project. Who of you uses Hibernate and relational databases? Okay, and NoSQL databases? And who of you has performance issues constantly? Not so many? Okay, cool. So you have already a good Hibernate experience, obviously, and caching experience. Who of you uses distributed caches like Redis? Okay, nice. So I like to introduce you to core Java stuff that is incredible fast, and I like to start a discussion. It's because it's always the same, because a lot of people cannot believe that Java is really so fast and can be used for in-memory data processing. All right, so Eclipse Store, we work on Eclipse Store, and this is also an Eclipse project. It's a part of Micronaut. Who of you uses Micronaut? Okay. It's also part of Helidon, and we have also integrations with Quarkus and in other frameworks. So the history is very long, actually. So more than 10 years we work on Eclipse Store, when we also worked on improving the JBoss Hibernate tools for Eclipse, because we wanted to, we were not able to solve the core problem, but we wanted to work on something completely different that is faster and more convenient to develop. So here is again in my opinion, the core problem. The core problem is that Java as a programming language, object-oriented programming language, is completely incompatible with databases from a technical perspective. And it's because of in Java we have an object model. We can do almost everything. So you can design it freely, you can use all Java types, you can use collections, you can deal with documents like JSON, XML, you can deal with graphs, even complex graph with circular references, you can deal with vectors. Everything is possible in Java. But it's different with databases. In Java also, we talk about object-oriented programming and type safety and clean code and good testable code. Who of you uses domain-driven design and yeah, okay. And what about test-driven design? Okay, so tests are important for you. So the code quality, so we are really keen on code quality. It's important, of course. Who of you uses Hibernate? Okay, how about native SQLs with Hibernate? Some, okay. What is native SQL? So it's SQL select in a string, right? Okay. What about type safety? Isn't it? Support from your IDE, like code completion, compiler checks, not possible. Good testable? Actually not. So it's completely different when we deal with databases, right? So, but doesn't matter, it's just database programming. That's a little bit different. Actually crazy. But the problem is a database management system works fundamentally different. Of course, a relational model is completely incompatible with the Java object model. And this is the reason why we have so various impedance mismatches here. So it's because object model is much more granular than the relational model, and subtypes are not supported. And then you have a lot of data types in a database, and they do not exist in Java. So what you're doing, you have to map the data types and so on. So a lot of challenges, and it feels like, so as a database programmer, it feels like you build your Java application around a database, right? So it feels like you have always to adapt your object model to the database model. This was my personal experience and the experience of my folks in a company. But this problem, of course, is solved because we have object relational mapping. And with the NoSQL databases, it's pretty much the same. It's because they introduced new data structures like graphs. Then we have the object-oriented databases. We have the document databases or key value stores, but they all are not able to deal with your native Java object model. So you need a conversion between Java objects and JSON, right? Or even the graph databases, they introduce a graph model, but their graph model is incompatible with the Java object graph model. So you need a mapping as well. And this leads to further challenges and consequences. So there you find a lot of articles and websites in the internet about this topic. So obviously it is solved because we can store some data in a relational database. Come on. Of course, so we have object relational mapping, and when we included our the JBoss Hibernate tools in our IDE, then we saw that the customer projects were certainly very slow from plain SQL to JPA in Hibernate. Why, actually? It's because object relational mapping is very expensive. In practice, so we measured, it mostly doubles your query time. So, of course, Markus, you have to use caches for that. Then you can accelerate your queries. So, okay, then let's use Hibernate caching. Then we measured, even if we fetch data from a hot EH cache, it took milliseconds mostly. And we were like, how can this be possible? Because I grew up with assembly programming with this Commodore 64, and when I executed an assembly program, it was executed in microseconds. So how can fetching just data from a hot EH cache be so slow? In milliseconds, come on. It's because of object relational mapping, because the objects are serialized and deserialized when you access a cache. And this is really expensive latency. But there are more problems, so the list goes on and on. When we have a distributed application, so who of you develops distributed applications? Okay, so then we have further challenges, and it's because of if data is changed in one of your nodes, and you store data in a database, then your node and the database are in sync. The problem is all the other nodes are not in sync with the database. Okay, then we can change our cache strategy and put just a cache between the application and the database. Now we have to maybe deal with a distributed cache. So another complexity added, and so on. If we have more load on the database, maybe we use a database cluster to distribute the load, and so on. So it gets more and more complex with microservices. We add another complexity, and sometimes database is not fast enough, maybe for searching, and caches can't be searched very well. So maybe use a search server like Elasticsearch. Who of you uses Elasticsearch? Okay, yeah. So this is very common, and this is the architecture of a common enterprise application, right? And it looks very complicated. It is. A lot of different tools are required, and then there are a lot of different database types. It's because of for any specific use case, you need a special database, right? So who of you uses a graph database, for example? No one? Okay. Document like MongoDB, and okay, so because the data model of the databases are very limited in comparison to Java, and this is the reason why they are perfect for a specific use case and maybe not suited for a different for another use case. Like the time series database vendors will tell you if you have sensor data, we are great, but maybe if you have really complex data, maybe we are not a good fit. And this is the same with graph databases. They will tell you if you have sensor database, maybe graph database is overkill, use a time series database. And with Java, we can deal with everything. In-memory data processing with Java looks very different. As I mentioned in the keynote, we have a great data structure in Java. It's the Java object model, and we can deal with everything. I saw a great slide on LinkedIn where there was a guy who published this graphics where he showed if you have these data, then there are some arrows and they lead you to the graph database, and if it's other data structure, then go to a time series database. Super complex, and in Java we can handle everything. That's great, cool. We also have a great query language with Java Streams API. Have you ever tried searching and filtering with Java Streams? Yeah, okay. Was fast, extremely fast. So we did tests with gigabytes of data in memory, really complex object graph with circular references and thousands of nodes, and it's executed in microseconds. And when we talk about performance of database, we talk about milliseconds. And this is 1000x faster when we execute equivalent code with Java. And even Java developers sometimes tell me, come on, this can't be true. I have a small demo actually. I wanted to share with you. Maybe some of you have already seen this demo. This demo shows here we have a we have a bookstore demo. The code is on GitHub, by the way. And by the way, it needs internet connection. It doesn't run. Oh my goodness! But maybe you can see the URL. It's a live demo in the web on a website. You can check this out. So two applications are running in parallel. bookstore demo, and both are bookstore demos, of course. 250 gigabyte of data. One is built with the JPA stack, with Hibernate, Cache, and a PostgreSQL database. And the other application is built with pure Java. We use Java Streams API for searching and filtering, and we use Spring Data for executing the JPA queries. In the live demo, you can see that all these queries are executed with core Java between 10 to 1,000 times faster with core Java. Yeah, you can check this demo. Maybe I can show it at the end of the session again when it's running. So incredible fast. And this is the reason why in-memory computing with Java is already used by many companies out there, like banks, building high-frequency trading applications, or gaming companies. They need best possible performance, and so they cannot accept millisecond latencies. Impossible. We need microsecond transaction time. So use core Java. Then we have, of course, the costs. Database as a service in the cloud is pretty expensive. This is just an example of PostgreSQL as a service in AWS. There are different options you can choose. So it's just one option, one region. Here we have 2 CPUs, 8 gigabyte memory, costs around $4,500 per year for one node. Okay, so the more nodes, of course, you need, your price will double, triple, and so on. The same amount of storage by using a cloud object store costs $300 per year, super cheap. It's just storage for binary data. So you save 99% of data storage costs, and we do not talk about license fees for a database. Remember this. This is very important. So the only thing missing in Java is there is no persistence existing. So this is the reason why we use databases, of course. And Eclipse Store is now a solution that provides persistence to Java. It adds ACID-compliant persistence to Java. It enables you to store any object graph, any kind of object graph with any complexity by using any Java types, collections, whatever is possible in Java, can be stored persistently on disk by using serialization. So it uses the Eclipse serializer to create a binary representation of your object graph and stores it on disk by just calling one store method. And vice versa, it can retrieve data from your disk and restore the object graph in memory when needed. And you not only can load the whole object graph in memory, you can also load it partially. So you can load subgraphs and restore subgraphs in memory when needed. And this allows you to design any kind of object graph, so any kind of object model, and store it on disk. Or store it wherever a binary can be stored and restore it in memory when needed. This is very easy. It's just a Java library, it's just a dependency. And the functional principle is also very simple. So in memory, you just need a root object. It works like a tree in memory. So you need a root object, like a swing tree. Who of you has developed with Swing, Java Swing? Okay, wow, becoming older and older. So, okay, root object, and every object that is reachable from this root object can be stored persistently on disk. So this is very easy. And yeah, just a root object, and then we can add some objects here and execute a store method. And then a binary is created and stored appended to the file storage. So I add some more objects here, and I execute a store method, and then another binary is appended to the file storage. And each store is transaction safe. It's a all or nothing, atomic all or nothing operation. We have a transaction journal, and so it's guaranteed that the data is really persistent on disk. So, and you can use the whole object graph for caching or for in-memory data processing with pure Java. And you have ACID compliant persistence. So now you can add any object and store, and so these snapshots will add more and more binary data to your disk. This is how it works from functional principle. Persisting object is easy, just call one store method. That's it. And then there you have multiple options. So you can store the whole subgraph or just the next reference. So this is you have more options by the API. Okay, for using this as an in-memory data processing application, you have to care for the object graph, and it's because all users now navigate on the object graph, and they have access to the same object graph. Because this is now, you can use it. It is not an in-memory database, but you can use it as a kind of in-memory database, because you can store data, you can query data, and you can now persist data. So you can use it for just caching or really for a whole complex data processing. For dealing with concurrency, you can of course use the core Java concepts for concurrency. But we provide you a simple API that simplifies concurrency handling. This is a locking API and makes locking very easily, because a lot of database developers, they told us the last 6 years, I don't want to deal with concurrency in Java, so in database programming I can just write a transaction. This is so simple for me. Okay, now you have a locking API, and it looks similar. The code is as easy as writing a transaction. So this is really not a problem. Not anymore. So when we start such an application, what happens? So when we start an Eclipse Store application, Eclipse Store will load the whole object graph into the memory. But this is very important. No data is loaded. Just the object IDs are loaded. So there's not much data to create the object graph in memory. Then it creates your object graph in memory. And you as a developer, you can decide whether you want to preload data or just load data on demand when needed. So this is your decision. It depends on, do you need fast startup time, or is startup time not an issue for you? Then you can preload more data. And if not, then data is only loaded when you access an object or when you call an object. But just executing a get method. So this is fully object-oriented. Call get customer, and then the engine will load the customer with all references into the memory. It merges directly into your object graph. So there are no more classic selects. This is fully object-oriented. Lazy loading. As I mentioned, if you just want to load a subgraph, then you can just load a subgraph into the memory. So this means you can deal with small memory sizes, and you have 100 gigabyte of database, for instance. This is possible. So very important, you don't have to load the whole object graph into the memory. All right. So lazy loading is also very simple to use. Searching and filtering, I think that it's pretty clear. Just use Java Streams API. As we create more and more binaries in the file storage, your file storage will grow more and more. I guess the functional principle is clear so far. Okay. Mostly now there are questions coming up. Mostly a lot of questions coming up. Okay, sounds cool because I had the idea 10 years before you had the idea. A lot of people used serialization for storing objects before we started doing that. But what is if the schema changes, or if my classes change? So there are a lot of problems. How do you scale it horizontally, and so on? And I would say 99% of all of these questions are and challenges are solved. We have solved this the last 6-7 years for schema changes. So if your classes change, we provide solutions so-called legacy type mapping. The engine loads an object into memory and compares your object with your class. If there are changes, then the engine can solve it automatically. So at least for the simple cases, you add a field, you remove a field, you rename a field, you change primitive types, that can be solved by the engine. For more complex cases, you can define a legacy type mapping. And then you store the object again, and then you have two versions of your object in the storage. The latest version, of course, and older versions. And you as a developer, you can decide whether you want to keep all versions in your storage or let the Eclipse Store garbage collector remove the older objects from the storage. So we have a kind of garbage collector that cleans up the storage constantly behind the scenes. You don't have to care for that. You can configure it. It can be configured very granular. Of course, I should have just like an animation for that. Hopefully. Yeah, this was my garbage collector. And here we can see just a small class. And we can see there is nothing specific required. So you don't, for using Eclipse Store, you don't have to use specific to implement interfaces, or there are no specific annotations to use. You can use pochos. So Eclipse Store can deal with pochos. No requirements to your classes. That's pretty cool. And you don't have to implement serializable, by the way. It's not required because we don't use Java serialization. We use the Eclipse serializer. That's built for this purpose, and it's highly secure. The Java serialization has this security flaw that you can inject malicious code very easily, and it can be executed through deserialization. And with the Eclipse serializer, this is impossible because the Eclipse serializer does not execute code through runtime. So deserialization attacks are impossible. And here is the complete stack of Eclipse Store. So the features, well, we have this legacy type mapping, we have the serializer, we have an implementation also for Android. Who of you develops Android apps as well with Java? Cool. Wow, that's great, because mostly at Java conferences there are not too much people developing apps. So you can use this library on Android as well. No more dealing with Room. It's called Room, like Hibernate. Yes. Right? They have also object relational mapping framework, and of course same issues using SQLite for storing data. It's always a challenge. So then we have this garbage collector for the file base. Then we have a file system abstraction. You can store your objects wherever you want to store it. You can also store it in different storage targets by just calling one store method. We have native backup functions, but you can also use database systems for storing the binaries and using the database systems backup strategies. This is possible. It's a question whether it makes sense or not to use a database system by using Eclipse Store. In some cases, some cases can really make sense. Sometimes a database system is required for a project, then maybe you have to use it. and then you can also use a classic database for storing the binaries. There is a REST interface that gets you access to the files storage, and you can browse through the storage data in your storage, and a graphical user interface where you can also browse through the storage data. But keep in mind, these data in the storage are binary data. This is not a database server where you can execute some queries. This is just a few on your storage on your hard disk. And of course, I mentioned already backup functions, 3 backup strategies. There's a JSON, a CSV converter for importing and exporting data, so it's an open format, and other formats and converters are a work of progress already. And all of this is Eclipse Store, so get the full package with Eclipse Store, and it's under EPL, so you can use it for commercial purpose, building closed source applications as well. You can use it with all JVM languages, and it runs wherever JVM is available. Also with GraalVM native images. The only requirement is Java 11 or later. Okay. The biggest challenge, there are several big challenges still existing. In the past, biggest challenge was, okay, it sounds cool, but single JVM storage, I need distributed applications, high availability, high horizontal scaling. We cannot deal with this. So this was the reason why we worked on a cluster solution for many years, and now the cluster solution is available. 3-4 months ago, we have launched this solution. It's a replication framework, and it also delivers a configuration file that generates the infrastructure you need for replicating this on Kubernetes and running this on Kubernetes. So you can create a Kubernetes-based Eclipse Store cluster, and then it's very easy. You can just deploy your Java application into this cluster, and then it automatically starts new pods and run your multiple JVMs in this Kubernetes pods, and then scales your application horizontally. And it provides you replication. So when you execute a store method, then the store is distributed to the whole cluster infrastructure. So you can replicate your object graph through hundreds, even thousands, or even more JVMs. So create any object graph, replicate it, and distribute it through 100 or 1,000 JVMs. That's possible. This is a single writer approach, and its eventual consistency. It's basically possible to introduce full consistency, but it's more complex because there are so many different levels of full consistency. So basic approach is eventual consistency. And so this enables you to build distributed monolithic applications or microservices very easily. And there's also a graphical user interface available, where you can set up a cluster, run a cluster very easily, just some mouse clicks, and that's it. So you don't have to deal with Kubernetes stuff. So there was one hurdle to use this in practice was commercial software so far, and now we open source it. So this is why I was in a hurry this morning. We decided to announce this at JCon, that we open source now the whole stack and start another Eclipse project on top of the Eclipse Store project. And then here is the full stack. Here's the Eclipse serializer as the core of the whole solution. Then you get Eclipse Store as a ACID compliant object graph persistence framework. And on top of that, you get the cluster solution with that enables you to build distributed Eclipse Store applications. And that's everything you need, actually. So some people ask us, so okay, sounds cool, but what if I have the huge collections? Should I load the whole collections in memory that I can search with Java streams? Ah, come on, you have a lot of I/O operation stuff. We were like, yeah, you have to segment your object models and segment your data. Maybe there are legacy data you don't need all the time. Yeah, you have hot data, you have backup data. So you can design your model freely. And most developers were like, yeah, but I need a fully automated solution. So this is, of course, we worked on solving also this problem. And we have now a new indexing API. So it's a bitmap indexing concept, and it's off heap, so it can be really huge. And with this indexing concept, you can search billions of objects in your storage in milliseconds. And we will also push this into this Eclipse Data Grid stack and open source it for you, that you have everything you need to build the fastest applications on the planet. And managers ask me all the time, should we really develop this in Java? So maybe you have similar discussions sometimes. And when you show this solution, when you can show that Java executes queries in microseconds, do you have any questions? You don't talk about performance anymore, because it's faster than any database on the planet, and it's core Java stuff. The learning curve is super flat because there is no specific database stuff to learn, no query language, no data structure. So now you have to adapt your model to our model. Then you can store it. Ah, big mistake. This does not work. Sorry, this is gone. This is just core Java stuff. There are only some types you cannot store. Threads, of course. So some types are not supported, but everything that can recreate it can be stored, and it's core Java stuff. And then the whole stack is under EPL, which means you can use it for commercial purpose, trouble-free, and also for building closed source applications. All right. So this is what we contribute the last years to what we have done the last 10 years, and was very challenging but big fun. And so now you can build distributed applications very easily, in-memory applications. You can use it as a primary data storage, but maybe you should not do that. So it's because of, in our experience, and this is why Eclipse Store is not that popular like it should be, and it's because of our goal was to find an alternative to Hibernate. Storing objects without object relational mapping, without a pain in the ass by database programming. And so we promoted Eclipse Store as an alternative to Hibernate and to relational databases, which means you don't need a database at all, just Java. And this sounds great for Java developers, mostly. Who of you thinks that's great? Okay, cool. Thank you. Thank you for supporting. But there are some people, they say this is not great because you need a database. And so in the end, your database team will give you a hint that this is impossible to store data without a database. So we had also to change our mind. So why fighting against database teams? This is not mandatory. So because when we saw this migration project, then we saw that we use it, or mostly they use it as an in-memory layer anyway, because mostly you will not migrate an application like a big monolith to a microservice infrastructure in 3 years, and then you shut down the legacy application and just start the new application. It's up and running and everything's great. This will never happen, not in my experience. So mostly this is a fluent process. So migrating service per service and more services And so you run two systems in parallel because you have to run your old system anyway in parallel. So you have to synchronize data at any point. Make sense? So yeah, this was our experience. So then we came up with, hey, come on, let's see it as a in-memory layer. We build it with core Java stuff. We use the power of Java, but there is still a relational database in your stack. It doesn't matter. You can, yeah, then you can do all the heavy data processing with your pure Java layer, and it will be extremely fast. But you make the database team happy because there is still a relational database, and it's important because you need it anyway. So now you can use it as a kind of caching layer, in-memory data processing and searching layer. And guess what happened in this intro workshops area later. At one point, there is a smart guy or a smart woman asking the question, yeah, but if this is ACID compliant and it runs in parallel, could we actually skip the database at one day? Oh yes, you can do that. Basically, that is your decision. So you can use it as a primary data storage or use it as a caching and in-memory data processing layer. All right, with MicroStream we provide, this is what I like to add, with MicroStream we provide a SaaS solution. We cannot do this within the Eclipse Foundation because it's a non-profit organization. We cannot charge you. At MicroStream we can charge you, it's a company, but we don't charge you. It's free. The SaaS version will be free. We have to charge you only for the infrastructure costs, but this is the concept. What you pay at AWS, we will charge you. Nothing else. And we provided, of course, you can use it on-prem. Then it's open source, and we offer enterprise support for this on-prem concept, but it depends on you. So, and then here we can see you can use these different database types, but you can also cover this with your Java application and then use it. Maybe just need only one classic primary data storage and not 4 or 5 databases running, because you can cover everything with Java. You have caching, searching, great searching features. There's a Lucene integration for full text search. You have the native Java object model, and everything is core Java. And you can implement, of course, in your in-memory layer Java logic. So it's like PL/SQL, but it's not PL/SQL, it's Java. Great, cool. All right, so we're at the end. If you have any questions, stop at the Eclipse booth. Maybe there is a little confusion because what I have announced, you cannot find this on our website so far. So it's because everything is new. So we decided through the driving time to JCon. So there, if you go to JCon, a lot happens, you know. So, but in the upcoming weeks, you will find everything clean and updated on the website. It will we will introduce a new Eclipse website, and then yeah, if you have any questions, ask the people outside on the booth. The team is there. This is the team who writes the code. You can ask really every single question, technical stuff. Thank you for joining, and yeah, have a great JCon. I hope you have fun at the party and enjoy the conference. Thank you.